Okay, good morning. Good morning again. So, what I want us to do is to finish that example of yesterday. I think we didn't get to really interpret the coefficients. And as we said, sometimes the dummy variables are a little bit tricky to interpret the coefficients. And then just talk about, in general, about the different specifications that we encounter a lot in economics, like for instance, the log of money, but on the right-hand side, we have an interest rate that is not logged. So how do we interpret that impact then? And then I want us to replicate what we did yesterday in E-views, to replicate every step in R. So to do that, in the meantime, you can drag this folder, which is in the exports example under practical application. It is the updated one. So if we go to in practical 2, it is, let me just sort it. It is in this last folder, practical application, the extension where the exports are updated to the end of 2024. And then just to keep it similar, I think eventually maybe you keep all your research projects somewhere in your documents folder, or so I'm going to show you a way that we can actually avoid working with directories, setting your work directory at all. Okay, so if you just arrived, if you can just make sure that you have this folder saved somewhere, perhaps on your desk folder in the extended exports application. And I think then we can go back and just finish that question on the interpretation, and then we can attend to this. I just need to quickly open it again. So it is the final model that we have here with the fit there. And then there's a question, interpret the coefficients. And then there's not an example here of a semi-elasticity, so we will look at that as well. And in order to do that, maybe I can also work here. Okay, so do we agree that the variables that are the double log part of the model is really easy to interpret? Those are straightforward. It only becomes when on the left-hand side we had a variable that is not logged, like consumption of, say, cigarettes. And then on the right-hand side we've logged income and so forth. something like that. Or in economics, typically we have interest rates, especially if it's real interest rates. Since it's already a rate, it doesn't make a whole lot of sense to take a log. If it's growth rates like inflation is already the difference of the log of CPI. So logging that is, we have to think, what are we doing if we do that? So we can have a level log or log level, double log, level. And then we have level variables, but that's not continuous. That's like a dummy 0, 1. A bond rate can be in level or a repo rate or money market rate that can be in level, but it's still continuous. It can take literally any value, say around 8%. It can be 8.01 or 8.05 or whatever. So those are the things that we deal with. I have uploaded a document that can be a little bit helpful, even though that doesn't include this type of variables, the discrete type of independent variables. And sometimes we use dummies to measure many things. It can be gender, it can be seasons. Those are also discrete variables, and we have to interpret the coefficients accordingly. In the under application, the practical application bit, the first one here, example 0, there is a little bit of information, and then there's more examples. So this only refers to the cases where we have a double log model or a semi-log model, and then the straightforward one is just in levels, where we just deal with y and x. Then we just interpret that in terms of units. And it doesn't matter if that is kilowatt hour, tons, minutes, any kind of measure. It can be money as well. It can be rand or whatever currency we're dealing with. So if we have a model, y is the intercept parameter, the slope parameter, and the independent variable. How do we interpret that beta 1 coefficient? It's always starting on the right-hand side, working to the left-hand side. So it's a 1 unit change in x will lead to a beta 1 units change in y, and obviously then we can add all other things remain equal, the ceteris paribus principle. And then for a double log, that's the easy one. That's the one that we most use. A 1% change in x will lead to a beta 1% change in y, ceteris paribus. When it becomes a little bit more complex, when we deal with semi-log models, so now either we can have the log on the right-hand side, or we can have the log on the left-hand side. So this is now neither a marginal value nor elasticity. So what we do is what effectively happens is that the slope will then be calculated as beta 1 times 1 over the average of x. How that translates is that what is easy for me to remember is if I can zoom in on this bit here. So if the log is on the right-hand side, then we know that we have to start with percentage. We always interpret from a change in X, a marginal change in X, a small change. What impact will that have on the left-hand side variable, the dependent variable? So since that is log, we start with 1% change in X will lead to, and now we divide by 100 to get to the impact in units. So we'll see some examples of that. And then the other one where we have the log here, we start here with a 1 unit change. And to get to percentage, we multiply by 100. And then that is 100 beta 1%. 100 times, whatever. If that parameter is 0.01, we multiply that by 100, and that is the percentage change. So to get these things wrong, if you write your report, like for instance, here's an example where the wage is logged as a function of education, then we will interpret that, if that is, these are the parameters, then we will say 1 more year of education will lead to 100 times whatever parameter is there. So 1 year additional education leads to 8% on average across everybody that was now in the sample, whether it was a cross-section or whether it was over time, but it's probably a cross-sectional application. So that's good news. That's good news too, if that is an actual result. And then when we have logs on the right-hand side and just numbers on the left-hand side, whether that is in units of cigarettes or packets or whatever the unit is. So if the impact looks very, very small, then sometimes we can also multiply by 10 and talk about a 10% increase in cigarette demand. I mean, 10% increase in price. How much will that lower the demand? And we can see typically this is quite an inelastic product. That's why revenue authorities target this for additional income, because this is a whole lot of additional tax revenue, but not so much lowering in the consumption. So this is basically the cases that we deal with, except for the dummy. Yes, Maureen.
So just a question for the steps. After running the model, we get the answers under example of level load model. Then introducing that 10% would be something that we do after.
Yes. Yeah, that is what we do when we get, that is part of asking that question, do the results make economic sense? When we came to this point and we've seen, we think we kind of tell the story now. We don't miss a whole lot of periods we haven't accounted or controlled for the global financial crisis or COVID, etc. So when you're at this point, you look at all of these, you think about how you want to interpret that. What's the right way to interpret that? We can see the first two parameters are simple elasticities. These are almost, it's very close to the dummies, since they are not logged. We will not log a dummy. What are we doing then? It's an intercept dummy. Since they are not locked. It's almost a semi-elasticity, but a semi-elasticity by definition is a derivative from y to x. So we can't interpret that way. So it's similar to it will be closest to this result if we want to get a fairly good approximation. We will take that parameter, multiply by 100, and say that's the percentage impact. Let's see if we do that, if it even makes sense. And how we interpret that. In this case, the COVID dummy was it only 2020 or only 2020? So, how will we interpret that? We will start with the saying during the COVID period, which was 2020. If it was 2020 and 2021, that you for a certain application said, well, both 2020 and 2021 it impacted employment. Then we will say on average for those years this was the impact. But now it's just 1 year, so the average doesn't make sense. So we just say for the COVID period, all the disruptions associated with COVID through supply chain and other disruptions, it lowered exports, not lowered the lin of exports, it lowered exports by 15.7%. And then you can ask yourself, does this even make sense? What do you think? I don't know. I mean, you can maybe just do a time series forecast from 2019 to 2020 and then see what would a time series model predict for 2020, and then look at the actual one and see, is it maybe 15% lower? So this is how we go about that. How about democracy? That's quite a large percentage. Maybe it's true. If we think about that first equation that we saw, I just want to take the dummy out here. If you think about this result, this coefficient down here now tells us that on average, exports were actually almost 33% higher. And that's the critical question that you have to ask. Is that what happened? And if you had a sanction dummy in, it will give you an average percentage for this period, for all the periods that you had a dummy in, by how much that lowered exports. And maybe you find a result that's not plausible, and then you have to rethink your model specification. For instance, if we add financial crisis in here, maybe we then just start adding too much demand on the data and you get a positive effect for financial crisis. And our exports did indeed lower slightly there. So a positive result would not be right. The commodity price boom, how much did we benefit during that 2004 to 2008? On average, roughly 13.3%. So that's something you can quickly do in your head. It's not the exact right number. There's actually a blog post which I don't reference here, but I reference it elsewhere, where the person that wrote that blog, it's Dave somebody, the name of the blog post is Dummies for Dummies, or something like that. We'll see it. I have it as a footnote in one of the documents. So there we learn that the right way to do this is not just that approximate way, but how we need to do it, and that is actually in here. I've written it out in down here.
Sorry, Prof, before you move on.
Yes.
On the COVID dummy, I think it was negative 15%.
Yes.
So, would it be accurate, another way of doing it, to not look at the whole time series data, but just to simply look at the difference between export between 2019 and 2020 and see if the 15% reduction applies?
But that is like below potential.
Okay.
So the actual one that you will see is already that it lowered the potential by 15%. Yeah, it's not that you can use actual data to calculate that. So if you like fit a trend up to 2019 and think about what, or maybe use actual, but it won't even work to use actual world income and such, because that will reflect the lower demand already. So you have to take like a counterfactual if COVID didn't happen, and that measure gives us like an indication of how much lower the...
Okay. And if potential equals actual in 2019, just hypothetically, could we then just apply the 15% reduction directly?
I think one shouldn't with these things. I think we should take it as guidelines and not absolute facts. Yes, it's in any case, if it's more extended number of periods, it's a little bit of it's an average over that period. If we can see that the disequilibrium post 94 was lower and then it's risen, but then it was like over and above democracy, then we benefit from the commodity price boom.
Okay, so the range.
Yes, yes. So how we actually should do this is, if I could make this a little bit bigger. So we will never say if COVID increased by 1 unit, or if the financial crisis increased by 1%. You know, what are we saying? So we always say during that period, it had a negative impact, changing demand, and now the calculation that we do is e to the power of that coefficient minus 1 times 100. So you can see it's actually, the actual impact is 14.6%, and the change is negative since the coefficient is negative. And the bigger the parameters become, the more wrong we become. So, but just as a ballpark, I think to treat it similar to a semi-elasticity is not completely wrong, but maybe for factual correctness in writing a research report, we do it that way. So whether all of that makes sense, that is a discussion at a different level. I think a different economist may look at this and say, yes, but you disregarded restrictions on trade or any negotiations, the AGOA agreement that we had that could change. So there's many dimensions to this, but that is where I said the techniques become straightforward, but the model specification is always the challenge. So the better you can account using economic theory for what you investigate, the better we are guaranteed with results. Yes?
Yes, I found that it is important to say I'm running a regression model. In order for me to start interpreting, is it important to consider first the R squared and it's Western statistic test, then the last figure, the 1.7828, and then joint significant by looking at the probability F statistic and F statistic, the one that has 0, 0, 0, and the last one. Is it important for me to consider those values before I can even jump into?
It's actually important not to look at it at all at this stage. And that's the next thing that we will discuss. Just because we are dealing with non-stationary data, the only values that we want to look at this stage is the coefficient values. We're going to learn about that the distributions of these parameters will actually change when the data is non-stationary. So the standard error will be biased, the t-stat will be biased, the p-values will be wrong, the r-squared will be wrong. I mean, at this stage, you can maybe look at it a little bit, but not write it up in your report. A wrong thing would be to say, look at my great r-squared. That is... So in the Engel-Granger method, there was always, or at some point, we did use a third. So the first step would then now discover if we can say this is our long-run relationship, our steady-state relationship. So we will test for co-integration, we will take the residual as the position of disequilibrium, we will build our error correction model, and then we can go, there was a third step, the Engel-U step, that would come back here and recalculate the standard errors, and then you can interpret them. But for some reason that fell out of use. In the Pesseron, in Shin and Smith ARDL model, if you read that paper, we see that when we prove co-integration with a bounds test approach, you can actually rely on super consistency to then to consider these distributions, these standard errors and p-values, etc. So this is basically what we will discuss for at least 2 days to come. But maybe for now, is this the end of the... So here are tests for co-integration, but maybe we refrain from that for now. That's our next... That's the next thing that we want to do. So maybe let's see if we can, all the knowledge that we have, everything that we've done here, if we can also do it separately using R. So if you have drag this folder to your desktop, you will see what I have in there. Oh, maybe just before I close that, I forgot to mention there's more examples in here, and here is examples like investment and then capital market rate as a proxy for the cost of investment goods. And that one is then in levels, and this one is in logs. So how do we interpret that? Here's the simple log-log model, and the only challenge is that sometimes I see people will write here a 1% increase in ln of k, log of k. To prevent that you will fall in that trap, write out the variable name so that you don't write, and don't put in brackets then log of k. then you shoot yourself in the foot. And it's also then what's the percentage impact in not GVA, log of GVA, but really output. So let's just look at, before we step away from this, because maybe we never go back to the money example. So now we start with 1 unit increase in this variable, and a unit in an interest rate is 1 percentage point, not 1%, 1 percentage point. So it goes from 8% to 9%, from 3% to 4%. Or we can also say 100 basis points. So if the interest rate increases by 1 unit, typically we will not write 1 unit. If you write it for a report, you will say 1 percentage point, 100 basis points. That will lead to a decrease, and now don't fall in the trap to say it's the log of that variable. So say gross fixed capital formation or investment, and then you have to multiply that by 100 to say what is the impact.
Look.
Yes.
So while you talk about the interest rate, I'm also thinking about inflation.
For investment?
No, in terms of interpretation. Since I usually hear the word basis points to do with policy rate and the other interest rates. In the case of inflation, we just be percentage point?
Yes. Yeah. Yeah, then basis points doesn't make, It's just in terms of monetary policy, we will hear the Monetary Policy Committee raised the interest rate, the policy rate by 25 basis points or 50 basis points. Yeah, interest rate will just say 1 percentage point. If it's currently at 3%, then we will all say what will arise from 3% to 4% have on consumer behavior or on money growth or whatever, or output. So here we have the option. It is technically correct to say on average during the transition to a democracy for that period, the dependent variable increased by 0.2 units. But that somebody in the popular press will not care about 0.2 units in the log of investment. So the better way would be to calculate the actual impact. And you see, if the coefficient is quite small, the error is also quite insignificant. And here's another example, like one where we measure wine in liters per capita. Okay, so let's then concentrate on what I've given you. I've just given you a folder, and I called it RAPPL ERSA. So you can find your own way how you want to organize your work. This can now, you can maybe work on project A and project B, and within that project you have a folder where you save all your applications. And then you can have project B and have also an application folder. And in this application folder, I now have just one analysis, and that's exports. So this is just a folder in that folder, and this exports have a data has a data file, and it has an R script file. So maybe you start another project, then it's always good to go to some kind of a skeleton script file that you have, so that you don't have to type in things from scratch, because you will read in data, you will call libraries, you will do things, and typically if you do regression analysis, at some point there will be conversion of data, you will do correlation analysis, you will graph your data, and you will do some regressions, you will table the results, you will graph the final model, the graphical model fit and the residuals and things like that. So this can be like a skeleton. Next time you analyze imports, so then you just copy this and make changes on this, or what, just however is easier for you. So if you double click on this now, it should open in RStudio. And before we look at anything here, maybe let us just think a little bit about what we deal with here.
Do you mind just going back?
Yes.
This file, or the one that you opened in RStudio,
Yes.
in which folder?
It's on I've shared it with you this morning under exports the practical extension, the folder 6, where the data has been updated.
Okay, the Google Drive.
Yeah, the Google Drive. Do you see it? I can mail it to you. Just go back to the shared link that I've sent you. It worries me if you say you can't see it.
Yeah, it's there. That's there.
If you have bookmarked it wherever you bookmarked it, you can go and look for it. In one of these, it would be in one of your subfolders here. Otherwise, go back to my communication that I send you with the link. And then go to, so if you go to the practical section, which is 3, and then you go to example 2, which is and then you go to practical extension exports updated, and then it's on top, depending on how it's organized. And then you just right click and download that to. So if you click on download, it will download a zipped version, If you right-click and say download, you will see that it will zip it and then it will show it up here. And then you literally just have to drag that to your desktop. And once you have that, you extract. And then it will still have a longer name. But if you then on that look at this, and this you then drag to your desktop so that it looks exactly like what I have here, a folder. I'll give you a minute or two to just get that.
So, just a question.
Yes.
What is the general principle on when to log your data? Because, I mean, yeah, just sometimes we don't, sometimes we do. Is there some kind of guideline?
There are some very informal tests that I've seen that can give you an idea, but intuitively, if we do macro analysis of this type, we tend to log all our macro aggregates.
Okay.
Because there's very often a little bit of an exponential. If you look at money or investment or consumption, it tends to, towards the end,
Start upwards.
yes. So if you log that, it tends to then, because logging it compresses a variable, it looks more linear, it's more suitable for OLS. And the interpretation of the coefficient is then also very, very simple, because we measure whether it's rand millions, rand billions, whether it's dollars, whether it's PPP dollars, then you don't have to be accurate to say if it increases by 1 billion rand. Because it won't make sense to talk about units. You have to say 1 billion rand, 600 gigawatt hours, whatever the measurement is. So it's just very simple in your report to say a 1%, never mind what the units are. But you have to mention what the units are.
Okay.
Otherwise it makes it very difficult to really get a handle of what are the results.
Okay. Thank you, Prof.
And then when variables can be negative, then the log of a negative value is not defined. Or when it's a growth rate, we tend to not log it. But it's not a hard and fast rule. It's not written in stone, cast in stone type of. In panel, you see, all these growth models where the dependent is the difference of the log of GDP or GDP per capita. And then on the right-hand side, it's often ratios to allow for comparability across different cross-sections. And now the question is, should I log the ratio of investment to GDP? Should I log government spending to GDP? And then you see variation there. I think then it almost becomes testing the correlation and looking graphically at it and looking at your results.
Okay.
I don't think there's really a good answer
So maybe
to.
descriptively first analyze.
Yeah, without it's not really engaging in data mining to just try every single form, but sometimes you just find that the levels of the ratios work better, and sometimes you find that the log of the levels work better, and sometimes even the growth rates instead of the ratio.
Okay.
Just to make, because the growth in investment of a small country can be a small absolute number, but the ratio to GDP or the growth rate should be comparable to a bigger country, but not the absolute number.
Thanks, Prof.
And also when we work with different panels, then the question arises, do we want to model it in local currency? Then you have dollars and yens and euros and rand and peso and whatever, all in the same mix. So then you can either use the dollar converted variables or the PPP constant, the purchasing power para constant dollars. That's almost, I think, perhaps the best to have results that's comparable across many countries, many regions.
The cost factors taken into account.
Yes, yeah.
Thanks, Prof.
But then on the other hand, if you work with countries in Africa that subject to currency crises, then the output increased like at a moderate rate, but because of a huge currency crisis, you see jumps in dollars. It's much lower or whatever, and then you distort the trend. So it's for that reason, sometimes even it can be, you can get better results if you model it in the local currencies. But I think the general approach would be to model in purchasing power paras the constant dollars. Are you all? Almost. Yeah. So I'm waiting a minute more, and then I want to say just a few things. So all that you should have now is a folder somewhere identifiable where you know where it is. Doesn't really matter if it's in your documents folder or even if it's on your C drive, if you want to put it here, it doesn't matter, wherever you want to put it. But you have to, either you can download one file at a time and it will not be zipped. That's probably also easy, and then just put it in the folder yourself. And this you can also name this, that it's our application, ERSA, you can name that also, whatever you prefer. So just give me an indication if once you're ready, and quite a few told me they've never run anything in R, but quite a few are experts. Is that right? I'm sure those of you that attended the cross-section course that Matt presented, you can, I did mention that it's available, but I just want to mention, so the earlier in the year, Matthew Clans presented the cross-sectional course and some panel. So the notes are here. If you go to his teaching tab, you will see the notes are there. So even if you didn't get to attend that course, you can work through. So just the only thing you have to remember is Matthew Clans, and if you forget, it's Poncho's her husband. you can ask her again. And the notes are there, and Jermaine told me the recordings, like we do here now, will be available in 2 weeks. So you can also then watch the recordings together with the notes. And he did quite a bit of panel and cross-section. And Professor Steve Koch also did 1 day on this course. It was also a 5-day course. And he has a little bit of, he also has information on installing R. It's also here. So if you, on this link, it also takes you through the steps. And if we get time, I will also show you how you can create. You can actually use RStudio to set up your own website like this, using the Quarto function there, or so this is, and you just register your own repository on GitHub, and then you can once you get to the point that you start developing, contributing R packages, I see Kenny is smiling, then you can also send it to the grant project, and it becomes one of those. I think at this stage there's more than 22,300 something user contributed packages, which is great, but it's also in a sense, I feel, if you use a software like Stata or eViews, Stata also has a big user community contributing, but it's almost like eViews has a little bit less of, it's got applications, add-ins that user contributed, but it's almost like eViews is one menu and you see everything that you can order on that menu. R is a little bit like Uber Eats. You know you want a certain pizza, but you have to look and see where can you get that. That's the feeling that I have. So while it's great, it's not learning. If you know nothing and you say, I'm going to school myself in unitary tests and I'm going to search through R now to get it done, it's difficult. It's all over the different packages, and the packages are written for specific purposes, and it's not always a complete application. Sometimes you still have to look up critical values and compare that with the test statistics, so there's a little bit of additional work. So I just wanted to mention that. And then in terms of that document, RStudio is the application that we use. We almost never go into R, the base language, unless you're a developer. As a user, we use the RStudio platform. So sometimes it's interesting just to see how things develop over time. Why would the language be called R? Why not P? P stands for programming. I don't, It's just simply because two guys, Ross and Robert, got together. And they were teaching at Auckland University in Australia. They used a language called S, which was simply, I have no idea what it looks like. It's a functional language, probably, I don't know, like SAS, or it sounds like SAS or SPSS. All of those languages start with S. And then they started developing R to teach the statistics students. And so that was way back in the 90s. It sounds a long time ago, but maybe not so much. And then a group of guys got together around 2009. So RStudio is quite recent. And they then only worked around the product R. And then very recently, only in July of 2022, with the latest conference, they said, we want to also go beyond R, and also you can now run Python through RStudio. It can do a whole lot more. So they rebranded to the name Posit. And that's also a strange name. I tried to read why they decided to call it Posit, but I have no idea.
So they can take it to online Posit Cloud.
Yeah, so I'm also still learning. So there's so much information available. So the truth is that we work in RStudio, but we have to install R as well. So RStudio needs R to run in the background, but not the other way around. And then I've given you, and this is also one of those things, there's literally an overload of information. If you go to any university like Princeton, Cambridge, all the big universities and small universities, many of them will have a support link somewhere with materials. Even the econ data guys, they have a substantial R resource. I haven't even put it here. I think and then there are a lot of free courses. You never have to pay to learn R. You can sign up for there's a whole lot here under this link as well. Or there are courses on LinkedIn, and maybe your university, you can through that access those courses for free. Coursera's got, but then it's a marginal price, like 260 Rand or something. So there's a lot of resources available. And you also get people that at some point in their career, they get bored with what they do, and then they upskill themselves to be a data scientist by learning these things. So if you later in your life get to that point, remember that's an option. A source that many people will refer to are these the documents. It's a textbook, but it's on a website that when you click here, you will access that. And or for data science now as an updated version. So if you click through from the hands-on programming, then you will first get to a first version, but then it will link you to the second edition of that book. A lot of people are making videos, but you know how to get the best ones. I think this one by Stephen Vasey, obviously from one of the paid platforms. It's quite expensive to do courses through them, through Code Horizons or Statistics Horizons. They charge like $700 for a course. But they're very good communicators, but they also have some free material. And then there's RStudio has an associated education page, which is also worthwhile. They have nice cheat sheets there. And obviously, I think RStudio are the cool guys. If you look at the R website, it looks like, I don't know, something dating back to before the World Wide Web. They had this this document and they just uploaded it. But they also have manuals, which we can click down here and you can download those manuals. So much information. But the RStudio, you can see this has also been developed with RStudio. And you can download, it's available here for free. So, yeah, so their website is definitely a little bit cooler than the, and they provide all of this for free, but then obviously on top of that, they do things for which they can charge money, like maybe this NASA link, and you know these are customers for which they then use their tool and do work for them, because they are they know their own product best. Yeah, so this is just as a matter of interest. So how they decided to, it hasn't changed a lot. If you activate RStudio, you get this 4 quadrants. And you have control over how you want to organize it. If you just open it, you will just get a console. There's no source code yet. That will probably come in the top half here, and the console will move down. And then here you have control over how you want to organize this. Do you want to show the plots up here and your files up here? How do you want to do it? And that, if you want to change that, you go to global options, and then you can change your pane layout and you select how you want it. You can also select, if you believe the white is not good for your eyes, then some of these are quite black. I don't know which ones. You know, if it's more comfortable for you to work on such a black screen, then you can choose that. I think the default is it text something? Which one was it now? A nice one is this one. So it's not complete. It's not white, not grey. So if you apply that, you will make those changes. Something else, under general, if you tick these, here you get control with your housekeeping. If you want to keep it clean, put all your projects in project folders. And if all of these are unticked, they will not linger open things, and then you move the folder, but it's still open here, and when you comes back, it says, no, I can't find it. So if you want to keep it clean, then you can untick all of these, and you can even say this as never, or you can put it as ask. You can even put that as never. Otherwise, you get images that doesn't really mean, if you're not going to use it, it clutter your workspace a little. So, but you can play around and see if you want to close it and next time go back and still have what you were working on last. You can do that, but you needn't. You can also just minimize and later come back. So it depends how you find it best, just as long as you know that you can do all of that. So how do you now, so you can basically, if you have a script file, You can always click the script file, run it, do whatever you want, close it, and keep it as a script file. But then within R, you will have to browse and find where you've saved it. So you make more work for yourself with a working directory and so forth. So I'm going to show you how to, even without having this open, you can let us maybe let us not. Let us just start with a clean slate in R. And now you have that folder with a script file. So let's define that as a project. So how we are going to do that is we are going to go to new project. So down here you will see now we have no project. So if you click on that and you say new project, so if you start on a new chapter of your thesis or whatever the case may be, why is this thing lingering here? And I say new, let's say I've already have the directory. So you click on existing directory, and now you're just going to browse. I have to browse to my desktop, and I have to browse to that. And I actually want to make this, the exports. I'm going to say open. And this is now a project. Not the big file, otherwise you will have hundreds of little projects floating around. Put them all in one folder. And then if you say create project, you will see what is nice down here. It now knows this is what we're dealing with. Whenever you say, if you don't have to create a working directory, this is now your working directory. If you write something out, it will go to the exports folder. So what are the steps? If you create, if you start out, you can also start out completely a new, create that folder and then put the script file in. But typically when you start a new project, you will have like a skeleton file that has some libraries at the top and some code, just basic code. And so you put that in a folder. You can put the data there as well. You don't need, you can move it there anytime after. And you just say, that folder is my project. And later I can create a project imports and I can create, or you can create a project chapter 1, chapter 2, paper 1, paper 2, paper 3. Whatever makes sense. So if you then, can I see, is everybody, are everybody on this? So if you click on the script file now, then we're in business. So typically you will have, yes?
So if you're using the online question one, can you export the CSV file?
I think you will just have to keep the file on your, somewhere on your folder directory and refer to it from there. But I think since it's so straightforward to install R, but I know you have rights, administrative rights. Yes. So when you get back home, then just install the. But we will see how we can navigate with that. But it is similar. This There's also that eViews Lite, which is an online that you can use online, eViews 12 Student Lite. And there also the data comes in and it's available, but if you close, the data is gone. So you will have to have the data on somewhere in your file structure. Okay, so I want to make it a little bit bigger. If you want to make, if it's too big for you, you can use Control and minus to make it smaller or bigger, just to put it in the how it's easy on your eyes. Control plus or Control minus. Yeah, so without going into much detail, I think we can go slowly through each bit of code. And later on, we can also look at running it, look at R Markdown or Quarto, where we can have text together with chunks of code. So comments, there are different ways of adding comments. I just use the hash. So all of this will not be executed. And these are, so how do we now execute data in R? Where's my cursor? So you can either highlight some text. There's different ways how we can execute. Typically, you can highlight a few lines of code and click on the run. So the run is, and what happens then is that the output will appear down here. Our environment is still completely open. As soon as we read data, it will appear here. As soon as we create new objects like a data frame. So in a sense, this R is, Python is a complete object-oriented language. R is object-oriented with some functional elements, I think, dating back to its origins. So everything that we create, a variable is an object, a data frame is an object. Everything that we create will, a vector, everything that we do. And then we will use those objects, apply functions to it, and we can send those results somewhere. One of the commands that's used is the piping command, and piping, when I saw it first, I thought it has to do with, it refers to a pipe that you smoke, but it's not. It pipes, it's like putting information in a pipe and it flows to a different place. But be honest, if you see pipe, what comes to mind? So you can use the piping operator to pass information. So let's just think about it bit by bit and run it. Down here we have the prompt. So on the console, you can also do many things. Add numbers together, type messages, create vectors, apply the mean to the vector, and so forth. But typically, you know, that's like once off looking at things. It's better to write the code once and then you can reuse it. What these commands up here do is just simply to clean up everything. So you can either click the run and it will run. You will see then in blue down here. Or you can use the shortcut key, which is Control-Enter. But be careful if you also use SAS often. Control-D in Stata, I mean, Control-D is run, Control-Enter is delete in Stata. In R, Control-Enter is run, Control-D is delete. So when I've worked for a long time in Stata, then I will definitely delete some code in R. And if you like 2 steps down the line, that is gone. So either you lose some work that you've done and go back, break out and not save, or you retype that bit of code. So you can try the shortcut code, a key Control-Enter, and you can see it runs again. So that's just cleaning up. But if you have set up your environment as we did, untick some of those boxes, you will enter in a clean environment. So you don't really need that. And since we have defined a project, we never ever have to, unless you want to use something in a different directory. Look what happens if I execute this. It will tell me this is my current working directory. So you don't have to define it, it's already defined. So the get WD command will tell you, if you now write something out, where will it go? So if it happens that you haven't defined a project, you've written something out and now you can't find it, just do get working directory to know where it is. Of course, you can, it's similar now to do this. This will like redefine what we've already done. I don't know if you put something else here, what will happen here? I haven't checked that. So this is as an alternative if you don't want to work with that concept of projects. And you can do it in 2 steps. We can assign that string to an object working directory and then set it. So that's a 2-step. And in R we use that smaller sign and the dash as an assignment operator. The equal sign is also used as an assignment operator. And furthermore, there is a way to type that. I think if you type Alt minus, that's a short way to get that. Instead of, because otherwise you have to do Shift comma, which is the smaller sign, and then minus. So now you can in one press it at the same time, press Alt and minus up there in the number. So that's the shortcut for the assignment operator. And then if you have a Mac, it's only that Mac doesn't have this C directory if you run it on the Mac side. If you have Parallels or any of those virtual machine software, then of course you can run it on the Windows side, but it's not, it works perfectly well on the Mac and run under the Mac OS operating system. Then the packages, as we said, there are 22,000 packages. So that's a lot of Uber Eats. Here are just a few that is used often, and this doesn't even include the ones that we will see when we do the co-integration test and the unit root tests. So this, this is one of those things, the installation you do once. You don't have to install these packages every time you run a script file. However, you have to load the needed packages. And I guess it cannot be harmful to load just a lot of packages, but the downside can maybe be if your application is data intensive and now you have a lot of information, unnecessary information, it can slow down your computer. I'm not even sure, but so best is when you at the point where you make use of a package, you can maybe put it there as well. The minute I want to use Stargazer, then you call it. The minute I want to use these packages, I call it there, etc., etc. As soon as I get to as soon as I get to the modeling bit, then I will work with the linear model package. So obviously, yeah, this one we'll have to call here if we haven't. But it will warn you. If you don't have it installed, it will warn you. If you have it installed but you haven't called it for this application, it will warn you. And R is one of those softwares that I've seen. Sometimes it's not the best. It's not one of those packages that you always want to be ahead of the curve and have the latest version. Because typically there are still some bugs. So it's a good idea to visit the user platforms, and they say don't use version 3.8.6. It's still a little bit bugsy, or something they use, IT language. I'm like, I don't know. So that's just, I think the latest I have 4.3.2, and Kenny, I think you will also have that. Yeah. Oh, you have the latest now. Okay, you ahead of the curve. So if this is the first time that you open it, you can probably install these packages, and you will see that it gives a lot of information. There's often red lines. So you think, oh my goodness, there's a lot of errors here now. Maybe I haven't installed it perfectly. Some of those are just warnings and then it's put in red. So it's difficult to know, but I think as long as you have a fairly recent version of R and R Studio, most of those are simply warnings that you can ignore to a large extent. So I don't know if you want to run, I will maybe just run one of them. So it will take a while if you install all of them now. The difference between installing a package and just loading it is like this is, I've seen some of the analogy, installing a globe into a light bulb into a light. That's installing. Putting the switch on is loading it. So if you run that package, it will tell me, hopefully, it's installed, sums checked, everything good. Otherwise, it will take a while to install those. The ones that we will use now is probably this first couple. So if you can install up to start, even Xtable, those ones. And so if you can run the first 6, and then in this program, we also make use of DPLYR, and you can run the last 3. First 6 and last 3. These others are the unit roots, Engel-Granger integration, and the time series modeling is also for unit root testing. So try that. If something doesn't work out, then if you get funny messages, we'll check that. And then we don't load all of them now. We will load them as we need it. Then we also learn which packages help us to do. If you get code, then it shows what package is used there. And if you've just done that, I think then we can break. Then we can take our tea break. And when we come back, we run all the codes bit by bit to see our models and compare it if it's the same as the results we got yesterday. Questions? I think you're all good. So far, so good. Okay, let's take our morning break and then we come back